Hello everyone, in this video we'll be solving problem 199 binary tree right side view. The problem statement is we are given a root of a binary tree and imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. In example number 1, this input can be represented in this form, and if we are looking from this side or the right side, we can only see these nodes, that is 1, 3 and 4. So the output is 1, 3 and 4 in the same order. Similarly, in example number 2, we don't have nodes on the right side of the root node. When we are looking from the right side to this current binary tree, after getting 1 and 3, the next node we can see is 4 and 5. Hence the output is 1, 3, 4 and 5. I hope you were able to understand this problem statement. This is a very easy problem and I'm sure it will not take too much time to understand how we can solve this efficiently. Let's switch to whiteboard and discuss how we can solve it. The simplest way to solve this problem is using DFS and Preorder Traversal. In Preorder Traversal, we first process the root node followed by the left node and then the right node. Because we are concerned with all of the nodes that we can see on the right hand side, Preorder Traversal will help us iterate through all of the nodes at each level from left and moving towards the right. And if we encounter a value towards the right, we'll replace the current value with that. To be able to replace the values of the node at each level, we'll use a dictionary or a hash map to maintain the records. We'll keep the key as the level or the depth of the node, while the value will be the actual value of the node that we have iterated so far. Let's run a simulation with this input. Node 1 is at level 1. Does it exist in the collection? No, it does not exist. So we'll add it to the collection with the value 1. Then we'll go to the left hand side, which is node 2. As there is no entry in the collection at depth 2 or key 2, we'll add the current node to it. And because we are doing DFS, we'll keep on going deeper on the left hand side. So from 2, we'll go to 4. Node 4 is at depth 3. As we don't have an entry in the collection for the key 3, we'll add it and continue forward. We'll repeat the same operation for node 5 with depth is equal to 4. As there are right nodes for 5, 4 and 2, we'll go back to our root node and traverse to its right side, which is node 3. The depth is 2. As there's already an entry in the collection with key 2, we'll replace the value of the entry with the current node's value, that is 3. Once the iteration is complete, we will return all of the values that we have saved in the dictionary or the hash map. With this solution, our time complexity is O of n, where n is the number of nodes in the given binary tree, and the space complexity is also O of n, as we are maintaining this collection with all of the nodes at each level. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing a dictionary of type integer and integer to maintain the collection of the depth and the node value, and then calling this helper method, which will help me traverse through the entire binary tree using preorder traversal. In this method, I am first processing the root node. If the key exists, it will then replace its corresponding value, and if it doesn't exist, it will add 1. I am then recursively calling the helper method, passing the left node and following that the right node. Once we have processed through all of the nodes in the given binary tree, I will have the corresponding values at each depth in the dictionary variable, which I am extracting its corresponding values and returning it. This code, when submitted on LeetCode, beats nearly 18% of the submissions in terms of runtime and 83% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.